This video is about functions. Functions. All right. The definition of a function is that it's a mathematical rule or equation that says that for every member of the domain, the x values, there's only one range. All right, let's talk about some of those things because that sounds kind of technical. So what we're going to do is we're going to talk about some things first. All right, if you have an equation that says y equals x plus 1, a simple equation right there that says y equals x plus 1. All right, let's look and see what these are. This is a variable x, this is a variable y. All right, we know from years ago that we could put in a t-chart with an x and a y, like this, and we could put in some values for this x and see what y's we get. We could put in 0, 1, 2, 3, things like that. And we put a 0 right there, we'd have 0 plus 1 is 1. So whenever x equals 0, y would equal 1. Whenever x equals 1, 1 plus 1 is 2, y would equal 2. And then put a 2 in there, we get 3. And put a 3 in there, we get 4. So these are the input values, the x's, we put them in, and we get a y, which is output. Well, the x's are called the domain. Okay, and usually they're always x's, but sometimes that could be another variable, but usually we recognize them as x's, and that's the input. Now the output, or the answer we get from that, is called the range. And like I said, other names for that is input or independent variable. This is the output or the dependent variable because y depends on x. All right, so since we know those two things, here is a relationship that we've seen before where there's a parentheses and an x value and a y value, a domain and a range. These are called coordinates or ordered pairs. Ordered pairs. All right, now, a function is a rule that states that the only way I can ever, if I ever plug in 0, I'll only get 1. I can't ever plug in a 0 and get another value, or it's not a function. All right, now we're going to clarify that a little bit. But as you can tell, these are all ordered pairs. 0, 1, 1, 2, all right, 2, 3, x and y value, domain, range, domain, range, domain, range, domain, range, input, output, input, output, input, output, input, output, and of course, independent, dependent, and so on. Now, these are the x's and these are the y's. All right? Now, as you can tell, the x's never show up again. The x's never show up again. And if they do show up again, which they're not if it's a function, but if they do, they'll keep the same value. It's like being married. You're only supposed to have one spouse. Okay? So 0, whenever x equals 0, it will always equal 1. That's the definition of a function. So if somebody gives us, this is called a set notation. If somebody gives us a set notation, and we have ordered pairs in here, like this, all right? Here's all these ordered pairs. Somewhere there's an equation like that that generated these ordered pairs. Now, the question is this a function? To determine if it's a function, we look at only the x values or the domains. Here's the x, here's the x, here's the x, here's the x. Do any of those repeat? Since the domain does not repeat, this is a function. Okay, since the domain does not repeat, this is a function. Now we have something like this. All right, the question is this a function? Is this a function? Well, let's look at the ordered pairs. And only the x values. 1, 2, oh, look at there. This domain repeats. So it's saying that this x value has two different y values for the answer. And when you have a function, that is not possible. So this is not a function. Not a function. Now we're going to study some other things that'll other ways to find out if we're given like a graph or anything else. But here, if you're given ordered pairs, the way to tell if it is a function is that the domain does not repeat. Now we don't care if the range repeats, okay, but the domain cannot repeat.